Hello, let's take a look at differentiation with the chain rule. So the chain rule is used when you want to differentiate a composite function. In other words, there is a function with something inside. So if I want to differentiate this, I will say I'm going to differentiate whatever is inside of the function multiplied with the derivative of that function. Then here are just some key points: the derivative of secant of x, cosecant of x, and cotangent of x. We will quickly use cotangent of x to find the derivative thereof. Here is an example. Differentiate the following: y is equal to cotangent 3x. So I notice if it was just cotangent of x, I could have used basic differentiation, but it is cotangent of 3 of x. So I can see here this is a composite function. So if I want to differentiate this, I'm going to say dy dx, and so the chain rule specifies I want to find the derivative of what is inside. So the derivative of 3x is 3 multiplied with the derivative of cotangent of this something. So the derivative of cotangent we just saw is negative cosecant squared of x, or cosecant squared of the something. So it's going to be a negative, so I'm just going to say negative 1 multiplied with cosecant squared of this something, but this something in this case is 3x. Now I can just simplify this: negative 3 cosecant squared 3x. Straightforward and simple. Let's take a look at another example here. Now for this one I will have to use the chain rule twice. So I can see here that I have a function y is equal to, and now in brackets, something raised to a power. So for my laws of differentiation, I know that if something is raised to a power, I'm going to multiply the power to the front and minus this power. But I see I will have to use a chain rule to find the derivative of whatever is inside. So let's think about the inside part here. So 4 cosine 3 of x plus 1. The derivative of 4 cosine, so 4 is a constant, it will stay the same, multiplied with the derivative of cosine 3 of x. This is a composite function. So the derivative of what is inside, 3 of x, derivative is 3, multiplied with the derivative of my function. So the derivative of cosine is negative, let's put the negative here in front, negative sine of this something, and this something is 3x. So the derivative of the inside is going to be negative 12 sine 3x. This is just the derivative of the inside part. So if I want to find the derivative of this y, I'm going to say dy dx is equal to the derivative of what is inside, which we have found to be negative 12 times sine of 3x, multiplied with the derivative of my major function. So the power multiplies to the front, so it will be 2, and multiplied with my same function, so this will be 4 cosine 3x plus 1, and 2 minus 1 is 1. So this will be my function. Of course I can simplify this. I can go and say negative 12 times 2 is negative 24 sine of 3x multiplied with, there's another constant here, multiplied with 4 cosine 3x in brackets plus 1. So I have simplified this function. Let's take a look at the last example here. We've got a little bit of a longer style question, and this goes back to our knowledge about derivatives and why we want to find the derivative of a function. For example, they tell us to find the equation of the normal to the curve of a function at the point where x is equal to root of 2. Now, I know that the derivative of a function gives me the gradient of that curve for the tangent, but if they use the word normal, so I want to find the gradient, then I have to find the negative reciprocal to find the gradient for the normal. So first of all I have to differentiate this. So this is y is equal to, now if I want to simplify this, I see it's 1 over, so I can make it a negative fractional 1, so it's going to be 4x squared plus 1 raised to the power of a half, because it is a root, but because it is 1 over this whole thing, so it becomes raised to the power of negative a half. if I want to find the derivative of this function, I'm going to say, sure, I'm going to multiply my power to the front. So this becomes negative 1/2 multiplied with whatever is inside. So the derivative of what is inside is going to be 8x multiplied with the derivative of my total function. So I'm going to rewrite this 4x squared plus 1, and I'm going to subtract 1 from the power. In this case, I will get negative 3/2. So this is the derivative of my function. I can simplify this a little bit further. Let's go and simplify it like this: 4x squared plus 1 to the power of 3/2, because it's a negative exponent, that's why I'm putting it over, and 8x times negative 1/2 will become negative 4x. So this is the derivative of my function. Now they tell me that I have to find the equation of the normal at the point where x is equal to 2. So if I wanted to find the gradient at a certain point, I'm going to say the gradient m is equal to where x is at a certain point. In this case, where x is equal to the root of 2. So instead of x, I'm going to say root 2. So negative 4 multiplied with root 2 over, now you're in brackets, 4 times root 2 squared plus 1 to the power of 3/2. Then what I can do here is I can go and simplify this. Let's go and check on the bottom first. So root of 2 squared is 2. 2 times 4 is 8, plus 1 is 9. Just here on the side, I'm going to say 9 raised to the power of 3/2, and this is the same as 9 cubed, so the square root of 9 cubed, and this is going to give me 1/27. So I can simplify this then as negative 4 root 2 over 27. And this is the gradient of my tangent to the curve. But they asked me for the normal to the curve. So for the normal gradient, I am going to find the negative reciprocal. So that will be 27 over 4 root 2. Remember, I'm going to flip the sign, and then I'm going to get the reciprocal for the normal. But now, I cannot leave my answer like this because there is a radical in my denominator, so I will have to rationalize this. So I'm going to multiply throughout with 4 root 2, and then I can rationalize it, and in simplified form I'm going to get 27 root 2 over 8. So this is the gradient of the normal to the curve. So I can go and write here y is equal to, so the gradient 27 root 2 over 8 plus x plus c. Now all I can do is I can substitute in my x and my y values, and then I can find my c value, my y-intercept. Now if I want to find the y-intercept, I already have a point for x. They told me that the x value is root 2. So now I have to find the y value. In order to do this, I will go to my original equation. My original equation was y is equal to 4x squared plus 1 raised to the power of negative 1/2. So I will go and substitute in root 2 into this equation. So now I will have to go and rewrite this. Y is equal to, and all I'm going to do is I will just immediately substitute in the value of x. So 4 multiplied with root 2 squared plus 1 raised to the power of negative 1/2. So root 2 squared, of course, is 2 times 4 is 8 plus 1 is 9. 9 raised to the power of 1/2 is going to give me 1/3. So now I have my x and my y value. So when x is root 2, then y is 1/3. So I can go and write y is 1/3 when x is root 2. So of course I want to find the equation of the normal, so I'm going to use my normal equation here. Y is equal to 27 root 2 over 8 multiplied with my x value, which is root 2 plus c. Now if I want to simplify this, of course, root 2 multiplied with root 2 becomes 2 times 27 becomes 54 over 8, so let's go and write it out. A third is equal to 54 over 8 plus c. So this addition on the other side will become subtraction, so I'm going to say negative 77 over 12 is my y-intercept. So now for the equation of the normal, I have y is equal to the gradient of the normal, which we have calculated to be 27 root 2 over 8 times x, plus the y-intercept. In this case, my y-intercept is minus 77 over 12. This is the equation of the normal.